Welcome, everyone. I like to start with the opportunity for anybody that is new or hasn't been here for a while to, if you're interested in introducing yourself, you don't have to. It's optional, but we always like to hear what people are up to, who's with us, what we're working on, and try to use this as an opportunity for networking, recruiting, discussion, anything we could do to continue to forward the field of AAM together and individually.
I'll step in. It's been a while. I think when I first started doing these, I think NASA was doing it,
Yep.
and then VFS took over. My name is Kenneth Barger. I go by Kenny. I work for the Federal Aviation Administration. I'm a principal maintenance inspector. I do not do anything with AAM, but I absolutely love it. I've been trying to get into that emerging technologies branch that we have, and not have much luck, but it doesn't matter. I still like doing these, and I appreciate all of you letting me join, just listen in, and learn as much as I can. So that's the reason why I'm here. I usually go off camera and be quiet, so I leave you all alone so you can do what you got to do, and you don't have to see this. So
Kenny, thanks for being here, and thanks for all you and everyone at the FAA do. We honestly couldn't do what we do without the FAA, and despite all the grumblings you might hear, we're extremely lucky in this country to have free government paid for ATC and some of the safest aviation in the world. That's thanks to you and your team. So we appreciate you being here and all that you do.
thank you, sir. Appreciate it.
Yeah, for sure. For sure. Would anyone else like to do an introduction or just an update on their tech or organization?
Oh, I'll pop in. I haven't been on for a while. I'm Michael Duke, the CEO of DBT Aero. We're developing a unique geometry. We believe that if people really want to get to net zero carbon by 2050, it's not going to happen through propulsion alone. And so in order to reach that, you really need a new geometry that requires significantly less energy in order to fly. So I love what VFS is doing with all of the new propulsion systems, electric, hydrogen, etc. All of those things are really critical. And we're bringing the other piece of that, which is a geometry that uses less energy for flight. So we fly farther, faster, and can carry more, both in volume and weight, for the same wingspan as any other aircraft that's out there. And we believe this is really the future of fixed wing, not vertical. But we love the things that are happening in vertical with advanced manufacturing and propulsion systems, and we want to leverage that for the fixed wing market.
Love it. Awesome. Great stuff. And I think I just saw DBT on a magazine cover, didn't I, Michael?
Yeah, In-Flight USA has our 3D printed aircraft, so it's a drone size aircraft. We're on the front cover in In-Flight USA this month, and an article is supposed to be in next month's magazine.
Awesome. It will not be the last magazine cover we see with you and or your aircraft, I'm sure.
Probably not.
Any other intros or updates?
Well, I'll take the opportunity to let everybody know the next week's TVF Public Service Working Group meeting. We will not have a speaker. However, we're going to be as a teamwork section to fully update our roadmap. We had a roadmap in the past, and basically what we try to do is look ahead 10 years, where the industry stands, the use case, the challenges, opportunities, and what critical areas that need to be worked on, including, but not just limited to technology, operational, training, autonomy, everything. So I would love to have everyone there. It will be coming Thursday, 18th. It'll be 2 p.m. Eastern time. So looking forward to have all you guys there. See you.
Fantastic. And Johnny will be at the Electric Aircraft Symposium next weekend, as will I. So anybody that's going to be there, we hope we can all get together Any other intros before we move on to events and news? All right. So I pasted some of the upcoming events, including the Electric Aircraft Symposium, in the notes. You can grab some information there about upcoming events, and also some links to our speaker today, who I'm going to introduce in a moment. I wanted to talk about news because I thought there were some interesting things happening in hydrogen. I noticed that Universal Hydrogen, some bad news, good news. I'll start with the bad news. Universal Hydrogen has shut its doors, which is a real shame. They were working on retrofits for the ATR 72 and the de Havilland Dash 8 to retrofit those to hydrogen fuel cells, and just some really cool projects, not dissimilar to what Zero Avia is doing, but I thought that was a bummer, and I hope they get picked up or merged what's remaining of that organization and their tech with someone else, because they did some really great stuff. And then I also saw this morning, Joby posted that they've completed a 500-mile flight with a hydrogen fuel cell powered version of the aircraft, which I didn't realize they were working on, and I thought it was kind of amazing and really exciting stuff. What's relevant to me there is that, you know, we always have to be thinking about how we're going to get to our 45 minutes of reserves. And when you're talking about a 200-mile-an-hour aircraft, that 45 minutes is about 150 miles. That's not insignificant for, you know, some of the battery-only tech that we see in the market. So to have that capability, I think, is kind of important from the range standpoint, and that becomes a safety issue as well. But I just wanted to throw that out there, you know, thoughts or ideas about what's happening in hydrogen.
Yeah, I think Joby picked up a hydrogen company. I'm trying to remember which one. They very quietly, 18 months or so ago.
I did not know that, but that makes sense now. So they've been kind of working on this under the radar, it seems like.
Yes.
Yeah, it's exciting stuff. I just wanted to share that. Any other thoughts or comments? All right, I'd love to move on to introduce our speaker then today, and I've included our speaker is going to be Joe Darden with Iridium Communications, and I've included his link to his LinkedIn page and their website in the comments section. But Joe's the director of aviation and business development for Iridium Communications. Prior to joining Iridium, he held several roles in the wireless telecommunication and manufacturing industries, including at T-Mobile and Cooper Industries. In addition to developing solutions and acquiring customers in all aviation segments, Mr. Darden is leading Iridium's autonomous and remotely piloted vehicle development strategy. Joe has over 25 years of experience in sales, channel development, business development for advanced wireless communication solutions in enterprise, retail, government, and wholesale sectors. And in his spare time, Joe is a certified beer judge, a Cicerone, and an award-winning home brewer. And I've got questions about that, but I would like you to start with
always more interesting than all the other stuff.
but we're here today to talk about satellite communications and everything that you're up to at Iridium. So before I hand it over to Joe, I'd like to ask everybody to mute so we don't hear dogs barking and lawnmowers in the background. I'll do the same. And with that, Joe, the floor is yours. Thanks for being here.
Thanks a lot, Andrew. So I will be in Oshkosh as well. So we can have some of those beer conversations, maybe over some samples that we can taste test. So I'm going to go ahead and share my screen. I'm going to turn off my video camera. So hi, everyone. Looking forward to seeing some of you face to face in Oshkosh later this month. And I know I've met some of you before. So thank you for having me. I'm going to switch off my camera and then put on the share screen so we can go through a presentation that I put together for you. 1 second while I figure out how to share this.
We just tested it, and of course, it worked absolutely perfectly. And that's always how it goes. The second you get more than 3 people on the line, it everything starts to malfunction.
Can we see it now?
There we go. Sure can. We see the globe.
Okay. Let me just. Okay. Cool. So, as Andrew said, my name is Joe Darden, and I believe that the Earth is round. Sounds funny to say it, but I think when you think about traditional communications, especially wireless communications, most of the systems are designed for the flat Earth, right? And if things like geostationary satellites and cellular communications, if the Earth was flat, the communications technology would work perfectly. So if you take a look at a geostationary satellite, the beam is cast from outer space in a fixed point on the Earth, and it starts to fade when you get to the 60th parallels. And then once you get to the 65th parallels, the signal kind of disappears. Now, if the Earth was flat, it would be a perfect communication system. It would cover the entire globe. But because the Earth is not flat, it's a sphere, it doesn't quite cover the entire planet. Cellular communications is a similar story here, right? You have a fixed tower, and this is any terrestrial-based communication systems. They have a limited reach because of a number of different things. One is that the cells are aimed at about an 8 to 15 degree angle to the ground because that's where most of the users are. And then secondly, when you get beyond the horizon, the signal doesn't bend with the horizon. And because the Earth is not flat, that technology has a limitation from a reach perspective. And so when you start to look at these things in a holistic perspective at the entire globe, we start looking at the fact that only 15% of the Earth has a ground-based telecommunications system, whether it be VHF towers, cellular infrastructure, et cetera. It only covers 15% of the Earth. Now, obviously, if we take out the oceans of that equation, it's only 37% of the landmass of the Earth has some sort of communications technology. And when you add in like a geostationary satellite, you get a pretty good spread, but you're still missing some critical parts of the planet, especially in the polar regions. And so that's kind of where Iridium comes into play, right? One of the things I like to emphasize here is that when it comes to critical safety communications and the types of things we're talking about for aviation, there's really no single solution that is the answer. What we really like to talk about is considering redundant systems, multiple link type scenarios for safety and critical communications. And so at Iridium, we think a little bit differently. We believe that the Earth identifies as a spherical object that rotates on an axis, and our network architecture reflects that. Iridium is a constellation of 66 cross-linked satellites. We call them space vehicles. Our architecture creates kind of this mesh network in outer space because all of the satellites they talk to their neighbors, and we can cross-link that signal across the network. We do have 14 in-orbit spares, so if something happens to a vehicle, we can swap one out. And so you see a maximum overlap at the poles with a minimum overlap at the equator, but all of the signal beamform tables overlap each other, so you don't have any place on the planet that does not have a signal. Gateway. So we actually have teleports all over the globe. We don't really have to use that. We can run the entire network through one gateway and teleport, but we do it to improve the efficiencies of the network. So we do have a landing teleport in Svalbard, Norway. We have one in Alaska and Fairbanks. We also have one in Punta Arenas, Chile, in the southern hemisphere. And then we have another DoD specific gateway that we land traffic at for Department of Defense. So I always like to insert some pilot jokes here. So how do you know the conversation is halfway over with a pilot? Enough about me. Let's talk about my aircraft. So this is an Iridium spacecraft. It's a space vehicle. This is the new satellite vehicles. We completed the replacement of our entire network in 2019. It took us 2 years. We started in 2017. We did 8 launches on SpaceX rockets, and we replaced every single satellite vehicle. So to do that, you have to fly the satellite up into an orbital plane. You have to deorbit the old satellite and slot the new satellite in. And then you deorbit the old satellite, you push it down towards the atmosphere, burn off all the fuel, and then it burns up upon re-entry, most of it. So we had to do that 75 times, and we did it without dropping a single call, which I think is a testament to some of the folks that work in our Space Network Operations Center in Leesburg, Virginia. That's where we have our versions of remote pilots in command. So our RPICs, their official job title is Satellite Flight Controller. So they fly all 80 space vehicles 24/7. And so I like to really talk about this as we talk about this type of an industry here, where we're talking about both traditionally piloted aircraft as well as moving towards autonomy and automation and remotely piloted aircraft. Iridium's been doing this for over 25 years. Our space flight controllers have 360 billion flight miles and about 16 million flight hours flying remotely. When we started in 1998, when we launched our first batch of satellites, we had over 50 space flight controllers that were, manually adjusting flight routes and flight plans, updating the orbital planes, etc., all manually by writing different scripts and pushing them out to the network. Today, we have 2 humans per 12-hour shift that control all 80 space vehicles, and they can fly the entire constellation from their iPhone. And the reason I like to talk about that story is because it took us 25 years to get to this point. We have slowly added in automation and autonomy and learned a lot of lessons along the way. And I think we're kind of at an inflection point here in the autonomous and vertical transformative flight industry. We're kind of at that same point where we need to start looking at adopting concepts of operations and scaling the business models so that it can be sustainable over time. So one of the things I like to point out here is obviously our main mission antenna here, but this little Lego block here, this is another payload that's called Aerion. If you're familiar with Aerion, what Aerion does is Aerion can hear the ADS-B transmissions. It's a listening payload, and they can hear the ADS-B transmissions from outer space, and they're able to provide aircraft tracking using the ADS-B signal globally. So anywhere on the Earth, around the Earth. So it's great. This is a significant gap filler for those oceanic flights that get outside of the range of a terrestrial-based ADS-B infrastructure. So, and that's something that is additional surveillance capabilities for the air navigation service providers around the globe. So Iridium's business model is a little bit different. We're just a network operator. We don't make anything and we don't really sell anything. So I know it's weird to say for a commercial company, but what we do is we license our chipsets, our core modules, to value-added manufacturers who then go out and build cool stuff. So these are the ranges of our current transceivers that are used, and a lot of these today are used in traditionally piloted aviation, as well as some of the growing markets in autonomous systems and drones. So it starts here, the 9523. This is on a lot of the transoceanic aircraft that fly oceanic. It's used in the cockpit for connectivity for voice and data communications for FANS 1A, data link, as well as safety voice. It's the connection for the pilot to the ground when they're outside of traditional communications. We have another smaller module that's coming out later this fall. Again, it's more of a telemetry type of a link. It's about the size of 2 American quarters stacked on top of each other. And then what we've released over the last 2 years are a few new transceivers. This 9770, that's a typo, should say 9770, that can transmit up to 22 kilobits per second. And this is the core module that a lot of our drone operators are using for command and control and backhauling, detect and avoid data when they get outside of traditional communications like line of sight radio, cellular, and C-band, etc. So all the way up to our 9810 transceiver, which we consider, I use air quotes on this, is to be broadband, but it goes up to 700 kilobits per second. And in a commercial transport scenario, it has the ability to bifurcate the data, so you can have your safety FANS 1A data going over one bifurcated data flow, as well as, you know, other aircraft sensor data and credit card transactions and other kind of aircraft domain applications that run over that. It's not still Iridium's play has been something that it's been core to how we've been able to maintain and succeed over time, is we stay in our lane, right? We're critical safety. We're not playing in the cabin services arena. That is not what we do. There are other satellite communications providers that provide cabin connectivity. A lot of the K-band suppliers, we are L-band, so it's a weather resilient signal. It's a little bit more narrow band, and it provides that critical safety system. Okay? So how does that translate into this non-flat world? Well, so one of the benefits of having multiple satellites in a mobile satellite system is when you go into a mountainous region, or you're in a valley or some other area of the world that's not flat, in a traditional satellite communications, you could be blocked when you go into these canyons and some of these other things. Well, Iridium satellites are constantly moving, so you're always going to be able to get signal. You might increase your latency a little bit if you have a lot of blocking happening, but you'll still be able to get a signal, right? And so this has allowed companies like Garmin to design solutions like the inReach, where you can actually carry this small little device. It's a companion to your cell phone, and you can go anywhere on the world and have messaging capabilities and tracking and the ability to hit an SOS button on the side if you are in a situation where you need some assistance. Another example of using Iridium in the non-flat Earth, we have a partnership with an organization called the Rebel Rally. The woman who founded this was actually a Baja 1000 racer. She was the first woman to win the Baja 1000, and she actually won it 7 times. So she's pretty cool. And so this organization, the Rebel Rally, it's spelled R-E-B-E-L-L-E, Rebel. So it's really focused on women who are re-entering the workforce. It's an empowering event, and it's a race through the deserts of Nevada and California, and there's multiple obstacles. It's a team-based event, and what they use Iridium for there is voice communications, and they have the competitive parts of it. They use a device called the Yellow Brick that actually tracks their waypoints, and they have a scoring system that they use. But they wouldn't be able to do that in those austere environments that they're operating in with any other type of a communication service. And so another example of how Iridium is used with heavy equipment manufacturers who are actually trying to make the Earth a little bit more flat for us. But one of these dump trucks, if it goes down on a job site, is about a $40,000 per day impact to the operation. And so they have Iridium transceivers and antennas on these vehicles that track different things like how many times the dump has been opened and closed, and how many times the door has been opened and closed, and how many times the engine's been up and down and running. They do predictive maintenance, so they can actually get ahead of any scenarios that could take one of these vehicles out of service, and it keeps their customers up and running. So folks from Caterpillar to Komatsu, Doosan, a lot of the heavy equipment manufacturers have a similar type of an operation. Another example of the non-flat Earth. Again, one of the things that Iridium has tried to do is remove a lot of limitations and think about different ways that people can use our network. And we've partnered with companies like Bivy, who has this device is something that a hiker can clip to their backpack and go anywhere, anywhere on the planet, and have the ability to hit an SOS button, message their loved ones, or initiate a tracking map that they can share with their loved ones so they know where they are at any point during their trip. Again, the Earth is breathtaking, definitely not flat. So this is an example of a maritime solution. This is a what we call a Certus 200 terminal that has up to 200 kilobits per second, and a lot of folks who go offshore that need some sort of connectivity for critical communications are able to utilize this service on any kind of a vessel. And then on larger vessels, we operate in what we call a companion service to do backup for the critical communications on, say, for instance, a container ship. Again, breathtaking, but definitely not flat. This is, if you haven't seen, this is the Polar Research Pod on the South Pole. And sometimes, you know, it's as simple as making a phone call home of where folks can use Iridium. This is a photo of an endangered Brazilian jaguar. And so they have a collar on them that has a tracking mechanism. So before we were able to do this with the Smithsonian Movement of Life Initiative, we didn't really know the living patterns of these animals, and now we can track where they are, where they eat, where they sleep, where they mate. And so when we introduce to try to repopulate the species, we're more familiar with how they actually live in the wild. They're doing this with Thai elephants and the Brazilian jaguar and a lot of different species that have challenges. And so they're able to do this and find out more information than the traditional method was just put a camera up where we think that they might be and try to monitor things. And now we can actually know exactly how they live. Again, even when you do find a flat spot on the Earth, we're just reminded of the true nature of the Earth, and that kind of gets us into the aviation safety services realm, which is an area that, from a vertical flight perspective, that's the area that Iridium really focuses on, is providing critical communications, only the necessary stuff that's needed to provide that critical safety. So just to go back a little bit about Iridium in general, because I know some of you on the call know some of the history of Iridium, founded in the late 80s, built a network throughout the 90s and launched it into outer space. Early 2000s, the company went bankrupt. And then the current company purchased the assets in 2001. And it's been operating under a new business entity since then, and went public in 2009, replaced the satellites between 2017 and 2019. And now we have over 2.5 million global subscribers. We're generating about 700, almost 800 million in annual revenues. And then we have more than 500 industry partners. So I talked about our value-added manufacturers that build the cool stuff. We have over 500 partners. And one of the things I liked on this slide is that we have more than 800 employees. I think we're right about that 800 number now, which is relatively small from a large corporation with a $10 billion market capitalization. Only 800 employees is a relatively small organization. And so we do in some cases act like a small company in some regards, which is fortunate, I think, because we have such close relationship with our partners, and that's really what drives us. And so we had to create an animation here because there's so many partners and so many logos. But this is just, an example of some of the partners that we work with across all segments. You'll see some that are familiar names in the aviation sector, but it's really anything from, aircraft, rotorcraft, general aviation, drones, even in maritime, buoys, weather buoys, you name it, polar research capsules. There's just so many different types of applications for connectivity from a global perspective. This is just a sampling of some of the types of hardware that are being used. And when we say connectivity, we really mean that in a general sense. Some of the applications that are being used on the Iridium network, I'll just give you kind of a quick, listing of these. So command and control for remotely piloted aircraft, network remote ID capable, communicating with UTM software architecture, safety voice communications, communicating with air traffic control, in-cabin voice applications and voice services, gathering sensor data from engine data, engine bus data, weather data, etc., backhauling sense and avoid and critical operation information, credit card processing and other aircraft domain services. So in the air transport market, Iridium is used for aircraft that are flying outside of traditional communications. Now, when we're in North America, that's usually when you're going in an oceanic flight. So if you're flying to Europe, if you're flying to Hawaii or Asia from the West Coast, once you get a couple hundred miles offshore, you lose any ground-based communications and it has to switch over to a satellite type of communications. And so Iridium is one of two global service providers that is aviation protected spectrum that's authorized to operate in the cockpit for that type of services, FANS 1A, if you will, and cockpit safety voice. So that's both for passenger transport and package transport. So, FedEx and UPS have their own aircraft and they fly globally as well. So with the expanded services and the new Certus network that has more broadband capabilities, that's starting to expand into more electronic flight bag, weather applications, and actually being able to deliver a lot more of a rich experience than just your traditional FANS 1A and safety voice. For air medical, again, aircraft flight follows, a voice communications back to the hospital, and now we're actually able to communicate in some regards. Some of the air medical service providers are starting to roll out services like live telemetry, live patient telemetry, so you can get a doctor to start doing the triage and troubleshooting while the patient is en route. Obviously, we have a large military play with our contract with the Department of Defense. A lot of similar applications, but a lot of other interesting things that the military does with connectivity. In the business aviation and air mobility space, it's a little bit different. It's usually typically voice communications, but we like to say it's the type of connectivity that you need, not necessarily streaming Netflix or any of the entertainment, the in-flight entertainment and connectivity options. It's really more critical communications to stay connected. This is an example of a drone service provider. This is a 15-foot wingspan aircraft that has about a 15-hour flight endurance. They're doing a pipeline inspection. So this is a really good example of a rural remote use case that has a lower safety risk. And this is really interesting. So there's a lot of time, energy, and effort being spent inside of the urban canyon. There's a lot of opportunity in kind of outside of the urban canyon. When you get into the rural remote areas, we've got over 5.5 million kilometers of power transmission lines, over 3.4 million kilometers of pipelines, and 1.3 million kilometers of rail. It has to be inspected, sometimes twice a month, other cases twice a year. But this stuff has to constantly be inspected, and using traditional aviation creates a safety hazard. So this particular customer that's utilizing this aircraft has actually saved about 6 human lives annually because they're moving to a remotely piloted aircraft and being able to inspect the infrastructure. Another thing about this aircraft, because you get a 15-hour flight endurance that you don't get from a Cessna or helicopter, you can actually, and because it's remotely piloted, you could actually hand off to a different pilot without having to land the vehicle. And again, because it's remotely piloted, the pilot doesn't have to be on the site with the aircraft. They can actually hand it off to somebody in a different time zone, etc., and hand over the controls and fly that aircraft. So this particular aircraft operates via a line of sight on takeoff. So the ground operations crew will launch this via a slingshot takeoff and landing mechanism, or it's actually a slingshot takeoff. Saves them about 30% of their fuel load. And then once the remote pilot takes over the aircraft, they give you a little wing wobble to let the line of sight pilot see the little wing wobble and let the line of sight pilot know they've taken over the aircraft. And so they can hand that off to multiple pilots throughout the flight. We did a white paper. I have a link later in the presentation that that Andrew will share with everyone that has the white paper, if you want to take a look at the white paper that we did with them about that flight operation and the process of getting that waiver and exemption approved through the FAA. Another use case, Swoop Aero, they've been using our services since 2015. They operate an aircraft to deliver vaccines. They've been doing vaccines since before vaccines were cool. They go to these remote villages. This is a village in Vanuatu. And so the guy with his hand raised, they have a video of him hiking through the jungle for 2 days with a cooler strapped to his backpack to deliver medicines to these small villages. They don't have the infrastructure that we're used to in North America. And so they're able to do that same journey on this drone with critical medicines and vaccines in about 45 minutes. So significantly changing the impacts of how they can deliver healthcare. This is another aircraft. This is a company called FlyLogix. They're based in the UK, and what they do is they fly offshore to inspect British petroleum oil rigs for methane emissions. So this is an interesting application that we couldn't do before we had the technology available. Because if you think about a traditional aircraft like a rotorcraft or a helicopter going out to inspect, they're going to disperse all the methane that you're trying to detect. And you wouldn't send a human up to inspect on those large exhaust stacks because it's just too dangerous. So this small, lightweight aircraft can actually take the measurements and detect methane emissions. And it's really a two-pronged thing, right? There's an environmental impact of the emissions, but also the BP is really interested in not losing the revenue because that's their product, is the methane. So if they're emitting, that means they're leaking dollars out of the rig. So it's really a dual purpose there. Another company called Boreal, they're based in France. They do offshore weather cyclone modeling. And so we couldn't get this type of information before either. So if you think of traditional aircraft can only get so low to take measurements before it becomes a safety issue. And then the surface-based buoys can only go up so high to get, relative high resolution data. So this aircraft flies in that middle space that we couldn't get to before, and they can go beyond visual line of sight. Their actual line of sight radio over the water can get them about 30 kilometers offshore. But when you're monitoring weather systems and a weather system comes in between your ground control station and your aircraft, you kind of need to fly 150 kilometers outside of the way. And that's kind of where they really need to switch over to satellite communications. So this is an excerpt from the white paper that we did and the link to the white paper. So this will be distributed to everyone afterwards. But this kind of just describes the line of sight, takeoff and landing, in route, transition to BVLOS. And then when they come back to land, they also transition back to a line of sight operator that can do the landing. So when we start to look at the landscape for all aviation in kind of an integrated airspace, it becomes challenging. And we feel that having interoperability and redundancy is the critical link to creating safety. All of these operations in this graphic require some sort of safety case or interoperability. Ground-based communications are really great because they offer a low latency, high throughput, virtually unlimited type of connectivity, but the limitations become when you get into altitude and just reach beyond the tower, and it just doesn't exist everywhere. So that's where you get a satellite type of a communication that can kind of fill in those gaps and reach all of the operations and be kind of a backup and redundant link. So again, when we start talking about things like what Europe is using with U-space, operating zones, etc., there's a core set of technologies that can be used there. And then you can augment that when you get to the edge of the U-space and beyond into the non-U-space areas to kind of create that continuity. So that's kind of what I had to talk about. I'll go ahead and turn it back over to Andrew, and if we want to, I wanted to reserve some time for question and answers. If I'm sure some folks have some questions, and turn it back over to you.
Outstanding, Joe. That was fantastic. And if everyone wants to unmute, if you have a question, feel free to do so. And are there any questions for Joe? I've got a couple that I'll throw out there, but I wanted to put it out to the group first.
Yeah, Joe, I've got a few questions.
Mark, go ahead.
Yeah, thanks. Joe, this is Mark Osman. I'm with Electra. We're an aircraft OEM. And I'd worked with Iridium maybe 20 years ago on a different program. And so my data is a bit old, and I want to just kind of catch up with you if I could on a couple of items. One was at the time you had only licensed your transceiver to a couple of aircraft, like avionics OEMs. Is your strategy still to keep that very limited, or is it pretty much anybody who wants to put an Iridium box as part of their product suite can do that?
Yeah, I mean, so great question. I mean, our business model is a wholesale model. So to the extent anybody has the technical acumen to build, a product, we're happy to have those discussions. That's really our customer, is someone who builds avionics. So there is some technical barriers when you get up into like the higher throughput stuff, like that Certus 700 on that slide that I showed. If you remember that slide, the 9810.
Yeah.
That requires a pretty heavy engineering lift from an RF engineering perspective, as well as a system integration. Some of the lower classes of services are, I don't want to say they're off the shelf, but it's really just a modem and an antenna. There's not a lot of the ground up firmware and RF work that needs to be done. So
Right.
a lift, but when you get up into that higher class of service, it's a pretty significant lift.
Okay, so you're not limiting it specifically just a couple of OEMs or something. All right, great.
Right.
And also,
from an aviation perspective, we try. I don't want to go sign up every aircraft manufacturer on the planet. We typically work with the avionics folks.
Right.
That. Like I don't know, there's thousands of aircraft manufacturers, right? And there's a couple of Honeywells, Collins, or some of these others that do that kind of work. But we've got probably, I would say today, about maybe a dozen to 20 folks that are building those types of systems.
Okay, that's good. It's different than it was. The other question is, at the time you were just switching from a circuit switch network to a packet switch network, and so all the pricing at the time was based on minutes. Is pricing now based on amount of data?
Yes, it is. So and it really depends on the type of connectivity you have, but yeah, usually the narrowband stuff is billed at the kilobyte level, and then the megabit type stuff in the more broadband, midband and broadband services, now we're talking about the billing by the megabyte. So yeah,
Great.
but it's all usage based. So
and then
even the voice telephony services are still on a per minute basis. It's a usage based. So
oh, cool. And then on the Arion ADS-B receivers, Do those work for aircraft that are flying fairly low level, 1,000 feet, 2,000 feet off the ground? Or are
Yep,
they
as long
only
as
for
you're
the airline?
transmitting at the right power level, like the portable carry-on devices don't have enough. They're not putting out enough output for the Aerion receivers to hear that traffic, but they hear it all the way down to the ground. So, and they don't have the same limitations as the, for example, just using an example, the FAA tower system. There's some areas where you won't get the full signal, right, because of a mountain or some other blocking that's just part of traditional tower-based infrastructure, whereas the Aerion signal's coming from our satellites, and so it can see, multiple satellites can hear the signal, and they aggregate that data. And so yeah, so you can go all the way down to the ground as long as you're transmitting. Yeah.
Does the Aerion feed, is that sort of a private feed that customer would subscribe to who wants that, or is it a feed into the FAA kind of public feed? I assume you have to make some money with that. So
yeah, so their target market is the air navigation service providers. There
okay.
are some companies like Passeur that have an API feed that provide the data on a fee type of a basis and subscription-based model. I believe that FlightAware is also using some of the ADS-B data from Aerion to kind of enhance what they're showing and demonstrating on the FlightAware stuff. So mileage kind of varies, but they're really kind of a back-end wholesaler as well. So they're really providing a service to air navigation service providers. That's their target market. So hopefully that answers your question.
Yeah, it does. Thank you very much.
And I see a hand up. Is it Maria?
Maria. Hi, Andrew.
Hey, Maria.
Hi, Joe. I am not an OEM. I'm with a engineering architectural infrastructure firm working with the FAA on the sort of the integration of the aircraft, the electric vertical takeoff and landing with the vertiport environment and helping them create design standards for vertiports. But I mean, the thing that jumped out at me, and I'm a novice. I don't pretend to understand everything, but
I am
said
too.
that-
This is my first day.
you
Ask lots
said
of good
that
questions is what I have to do.
you said that you had a limited number of people that could operate this from their iPhone. And the first thing that, I thought of was like, well, if you can operate it from your iPhone, can I hack it from my iPhone? And can you talk a little bit about
That's a great question. We have an intense amount of security. As you can imagine, the Department of Defense is one of our primary customers. So yeah, being able to operate and monitor the network from their iPhone, that's all an in-house, on-campus type of an application. So it's all firewalled and VPN and everything. So it's not like something that's publicly open to anybody to hack into. And so yeah, we have a multiple dual redundant system of security to protect the network from outside influence, if you will. So, but yeah, no, that's a great question. So yeah, it's,
Can you hear me?
but I will say that when we bring in somebody, a new, like say college graduate or what have you, like usually the first role is they put them on the front row of our network operations center, and they're a space flight controller. They're flying the network. That's like the entry level position, and then they get promoted to other roles from that front row. But that's here's the keys to the network, kid. Have fun.
Yeah, well, it's just obviously something that keeps coming up in cybersecurity, and
Yep.
I don't know how your company will may it eventually be involved with the air traffic type of management that has to happen, that needs to happen if it ever get to urban air mobility at the volume and tempo that needs to happen for them to make money. But the whole cybersecurity question is, it's disconcerting. And I don't know what that answer is, to just say, well, yeah, you can't hack it.
No, that's so it's a really good way to frame it up. And so one of the ways I'll answer that is a couple of different things. So traditionally, our FANS 1A data link, it's all done through AirLink and SETA. Those are the two service providers. And so they have co-located routers at our gateway. They receive the traffic from the space network, and then they secure it on the ground before it transmits over the air. That's our traditional feed. That's the way it's always been done. That's the way it was written in SC 222, in all of the regulatory documents like DO 262 and DO 343. That's the way it was architected. We've re-architected that based on the requirements that are coming out of Airbus and Boeing and commercial air transport, because they're thinking exactly the way you're thinking is, wow, this is not secure from the aircraft to the ground. Once it hits the ground, it's secure, but we need it to be secure, a secure link. So we're actually going into FANS 1A trials for our new network starting later this year. We're actually just standing up the Boeing lab now. We're testing, right? And that is a VPN IPsec secure connection from the aircraft to the ground and then to AirLink and SETA. So we're going into FANS 1A trials. We're already operating that internally, testing and doing that. So that's just an additional layer of security. And if you think about the way our network is architected, just purely Iridium, right? Forget about all the other satellite types of signals out there. Iridium, because we have mobile satellites, like when you're standing on the ground and you're connected to a satellite, the maximum time you're going to be connected to one satellite is 9 minutes. And within the satellite beam architecture, because it takes 9 minutes from a satellite to go from the horizon across, right? So the beam architecture, there's 42 different beams in a beamform table, those circles that were in that graphic animation. So you're switching beams every 45 to 90 seconds. So if, quote, big air quotes right here, like in our quantum world with quantum computing, if you were able to hack the signal, the digitally encrypted signal, and actually hack into that signal, it's only good for 45 seconds, right? Then you're gonna have to start over because the link is gonna hand off to a different. So there is some physical, just laws of physics type security in the network system itself. It's very unlike a geostationary satellite where there's one satellite, it's casting its beam and you're there all the time, or a cell tower where it's very easy to just put a listening device on a tower and hack into it, right? So there are some interesting architectural things that protect us from security, but that's not good enough, right? Securing on the ground, securing it from the aircraft to the ground. Those are the really additional layers that we're putting in.
That's all.
Outstanding.
Yeah, great information. I
so
appreciate that.
We just have 3 minutes left, so I had a couple questions, but I want to throw it out to the group to see if there were any others about the applications or the tech behind what Joe and his team are doing. So my question was really just sort of a summary question. I want to make sure that I have the application categories correct, and I wrote down 3 of them, but I want you to tell me if I'm missing any. So I wrote down voice communications. That's a pretty obvious one. And then command and control, you talked about for uncrewed vehicles. And then we talked about telemetry, telematics, and HUMS, which stands for Health and Usage Monitoring Systems. So we can keep an eye on our vehicles, the aircraft propulsion systems, power, everything else. What am I missing there? I don't think there's a navigation component. Is there, or is there?
There can be a location-based, like aircraft flight follow type stuff. That's being used a lot. That's a really small payload. It's about a 30-byte message that comes across to give me launch, altitude, heading. That's actually part of FANS 1A as well. But yeah, location-based, anything that's a packet of data information coming across the link is fair game, right? As like we talk about these applications, this is what people are using it for. There's really no limitation. You could use it for whatever you can come up with in terms of an application, right? But again, back to the security discussion, aircraft domain, not cabin domain. We want it to be limited to critical safety applications. And when you start getting to uncrewed, that becomes an interesting category of, well, how do we use this link? Like for an air taxi, like, oh, what if I need to talk to the passengers on board? Okay, well, that's a voice call, right? And on a speakerphone, or there's other different things you can start to think of how you use that. there's really no limitations of how you use it. I mean, there might be some regulatory things or regulatory stuff that hasn't happened yet, right? But purely from the fundamental perspective, you can the sky is your limit to use an aviation plane.
Well, and we just have a minute left, so I'll just finish out with this. I was going to ask, what are the applications that you're excited about for the future of advanced air mobility? And that's a great one, just the ability to have push to talk for anybody that's on board, crewed or uncrewed, to get some help. Maybe it's a crewed operation. I've got a pilot, but they slumped over or something like that. I need to talk to somebody quick. Having the ability to do that anywhere.
Garmin has had that service already in their cockpit, in their connected cockpits called the G56. They have what's called Auto Land. So what Auto Land does is it initiates a direct communication connection over Iridium, and the aircraft itself goes into the Auto Land procedure, and they can talk to the pilot. So if the pilot's slumped over, the Garmin cockpit, this is in operations today. They haven't had any real world examples, right? Which is fortunate. But it goes into an auto land procedure. Safety network can connect to the pilot if they're communicable, and they can coordinate the entire landing via the Garmin system.
Outstanding. That brings us right to time. Joe, this is just a fantastic conversation, great presentation, and it brought some great questions out of us. So that tells us it's a topic that people are interested in and would like to know more about. So we're going to post this video on the Vertical Flight Society YouTube page. Give us a couple days for that, and then I'll send it out to the team. And if you'd like us to include some information as well, bounce that to me, and I'll get it out to everybody.
Great, yeah, and I'll be at the event in Oshkosh if anybody has any more questions then, or follow up via email if you didn't get your question answered. So thanks a lot again, Andrew. Really appreciate the time and the audience.
Absolutely, and check out the notes. You're getting some very positive feedback in the chat notes. So thanks again, Joe. I'll see you in a week and a half.
Yes, sir. See you there.
Take care. Bye, everyone.
Thank you.